Hi friends, welcome back to C-Level Physics. My name is Srinivas, known to be B.S. Rao. In the previous lecture, we have come across some numericals based on cross product. In this lecture, we are going to discuss scalar triple product. Scalar triple product in the sense, by the name itself, multiplication of three vectors such that result is scalar. See here, scalar triple product. Triple in the sense three. Triple product means whose triple product here? Scalar triple product. Triple product of vectors as that result is scalar. That is the reason why it is known as scalar triple product, STP. Okay. If three vectors are multiplied such that result is scalar, then that kind of multiplication is said to be scalar triple product. Let us see. Here see, we have three vectors. Say a bar equal to a 1 into I plus a2 into j plus a3 into k. B bar equal b1 into I plus b2 into j plus b3 into k. And c bar equal c1 into I plus c2 into j plus c3 into k. Right? Now, here we have constructed one parallelepiped making use of these three vectors. See, here it is a bar, here it is b bar, here it is c bar. All the three vectors are meeting co-initial, means coterminous. These three vectors are coterminous vectors taken as the edges of parallelepiped here. Parallelepiped in the sense three-dimensional figure. It is what one three-dimensional figure. See, this is what B bar, here it is C bar, here it is A bar, right? Total it has how many sides here, faces here? Top face, bottom face, right side face, left side face, front face and opposite face here. Total 1, 2, 3, 4, right? 5, 6. 6 faces, right? This is what parallelepiped. So here given vectors are taken as the sides of parallelepiped. Okay, coterminous sides here. All the three are coterminous sides. These three vectors are taken as the coterminous sides here. Okay, all are meeting at origin somewhere here. At origin somewhere here, right? Okay, this is what x-axis, this is what y-axis, this is what z-axis, like that. Somewhere here this is z-axis. X, y, z, like that, right? Now, angle made by a bar with z-axis, that is theta. That is theta. See here, theta. Now, what is this side? A cos theta. This is what adjacent side means. Adjacent in the sense cos component. Definitely, they represent cos component. That is a cos theta. If it is a bar, this measurement means that is height of parallelepiped from bottom face to top face. What is the measurement? That is what is the height of parallelepiped means a cos theta. Why? Because if it is a bar, definitely it is a cos theta. A cos theta. Adjacent side. This is what opposite side. This is adjacent side. Okay. To get adjacent side, always we have to consider cos theta. Okay. Cos theta equal to see, this is right angle triangle. Cos theta equal to adjacent side by hypotenuse. Say this is x. Adjacent side x by hypotenuse means that is mod a bar, that is a. So x equal to a cos theta. This x equal to a cos theta. Okay. Now, what is a cos theta? That is height of parallelepiped. Right? Now, I am considering B bar cross C bar. See, B bar and C bar are somewhere here, present in the bottom plane of the parallelepiped. See, this is what bottom plane of parallelepiped. Okay, contained by two vectors, that is B bar along this way, C bar along this way. Right? B bar, C bar. If I consider B bar cross C bar, that is cross product of base vectors, means one is B bar and one is C bar. Now, how to find cross product? By taking determinant, that is I, J, K, below which components of B bar, that is B1, B2, B3, below which components of C bar, that is C1, C2, C3. See, what are the components of A bar? A1, A2, A3. For B, B1, B2, B3. For C, C1, C2, C3. So, those only written here. For B bar, B1, B2, B3. For C bar, C1, C2, C3. Now, what is the procedure? That is I cap into AD minus BC minus j cap into AD minus BC plus k cap into AD minus BC. Now, where is I cap? Somewhere here. I cap is somewhere here. Now, exclude row and column containing or connecting I cap. See, exclude row and column connecting I cap. We left with all the four components B2, B3, C2, C3. Okay, take them as A, B, C, D. Now, I into AD minus BC, that is B2, C3, B2, C3, B2, C3 minus B3, C2, B3, C2, B3, C2. Am I right? Now, minus J cap into. This time, exclude row and column containing connecting J cap. Now, leave this one. Now, exclude this row and column connecting J cap. Like J cap is somewhere here. Exclude row and column connecting J cap. That is, we left with all these four components. That is B1, B3, C1, C3. Now take them as A, B, C, D. Now minus J into AD minus BC. AD minus BC. That is B1, C3, B1, C3, B1, C3 minus B3, C1. B3, C1. Right? Plus K cap into this time. See, somewhere here K cap is there. Now exclude this row and column connecting K cap. This time exclude this row and column connecting K cap. Now exclude this row and column. We left with B1, B2, C1, C2. That is AD minus BC. Take them as A, B, C, D. Now this time AD minus BC. That is B1, C2, B1, C2, B1, C2 minus B2, C1. Minus B2, C1. Okay. That is what B bar cross C bar. So B bar cross C bar equal to so and so. Right. Now this time I am taking A bar dot. See, A bar is somewhere here. B bar, C bar are somewhere here in the plane of bottom plane of the figure. Right. If I consider A bar dot B bar cross C bar. A bar dot B bar cross C bar. Before that, I am taking modulus of B bar cross C bar. Modulus of B bar cross C bar in the sense, modulus of B bar cross C bar. See here, B bar, C bar, nothing but coterminous vectors of bottom plane of the figure. Okay. What is this bottom plane? See the shape of this bottom plane. It may be square or rectangle. It may be square or rectangle. Now, if a square or rectangle or parallelogram formed by any two vectors, then the magnitude of cross product of those two vectors becomes equal to area of that figure. Now, what is that figure here? As far as bottom is concerned, it may be rectangle or square. Now, if I take modulus of B bar cross C bar, by the definition of cross product of vectors, modulus of B bar cross C bar becomes equal to base area. This is what base area of the total figure. Base area of the total figure. That is mod B bar cross C bar is equal to base area of parallelepiped here. Parallelepiped. Okay, base area of parallelepiped. Right? Now, I am taking B bar cross C bar. That is A bar dot B bar cross C bar. If I take A bar dot B bar cross C bar. See, to get scalar triple product, we have to consider three vectors. We have two vectors already, B bar, C bar. One more vector, that is A bar. I am taking A bar dot B bar cross C bar. Dot product of A bar with the result of cross product of B bar and C bar. Okay, that is A bar dot B bar cross C bar. Right? Now see, if I take modulus of A bar dot B bar cross C bar, that equal to, see, A bar is something like A bar, B bar cross C bar something like B bar. Right? The dot product of two vectors always equal to A bar dot B bar equal to mod A bar mod B bar cos theta. Am I right? That is AB cos theta. AB cos theta. A bar dot B bar equal to mod A bar mod B bar cos theta. That is mod A bar means A, mod B bar means B into cos theta. This is what definition of dot product. Here also B bar alone one vector, C bar alone one vector, but B bar cross C bar it's not one vector. That is it's not two vectors. That is unique vector. Okay. Cross product of two vectors always a unique vector. Of course, B bar alone one vector, C bar alone one vector, but B bar cross C bar is unique vector. That is dot product of that vector with A bar. See, that is the reason why I am taking B bar cross C bar taken as B bar, capital B bar. For example, means B bar cross C bar is another vector, not two vectors. That is another vector. So something like it is capital A bar, B bar cross C bar is capital B bar. As per here, see the dot operation here. A bar dot capital B bar. That is mod A bar mod B bar cos theta. That is AB cos theta. Now go with that relation. That is A bar mod of A bar dot B bar cross C bar in the sense. Mod A bar means that is mod A bar capital A bar means small a bar here, that is mod capital A bar means mod small a bar. Again mod B bar means mod of small b bar cross C bar into cos theta. Here what is theta? Theta is angle between A bar and B bar cross C bar. Of course, what is the direction of B bar cross C bar here? B bar cross C bar. B bar is along this way, C bar is along this way. As per the definition of cross product of B bar and C bar, the resultant of B bar cross C bar always perpendicular to B bar, C bar and plane of B bar and C bar. See, this is B bar, this is C bar. This is what plane of B bar and C bar. As per right hand thumb rule, take the curling of B bar cross C bar in the sense, take the curling of four fingers of right palm after stretching like that. That is, take the curling of four fingers from first vector to second vector. That is in anti-clockwise sense in this plane. See, this is the plane of B bar and C bar. This is the plane of B bar and C bar. Now stretch your right palm such that thumb is perpendicular to remaining four fingers. Now place your bottom edge of the right palm after stretching like that. Okay, and correct or touch the bottom edge of the right palm after stretching like that with the plane of B bar and C bar. Now take the curling of these four fingers from B bar to C bar. From B bar to C bar means like that, anti-clockwise sense. Now see, the thumb indicates the direction of resultant, that is B bar cross C bar. The direction of B bar cross C bar is in the direction of thumb after taking curling like that. Okay. Now see, thumb vertical upwards. Therefore, what is the direction of B bar cross C bar? Vertically upwards. That is B bar cross C bar, which is normal to B bar, C bar and plane of B bar and C bar. Right. Now, this is what A bar, this is what B bar cross C bar. Now, what is the angle between these two? Theta. Okay, here theta is the angle between, see, theta is the angle between A bar and B bar cross C bar. A bar and B bar cross C bar. What is the angle between these two vectors? That is theta. So, as per the definition of dot product, mod A bar, mod of B bar cross C bar into cos. This is one vector, this is another vector. Now, magnitude of first vector multiplied by magnitude of second vector multiplied by cosine of angle between these two. What? Cosine of angle between these two. That is theta. Right? Cos theta. Okay. Now, what is A bar? Mod A bar means A. Mod A bar means A. That is A cos theta. A cos theta. Writing somewhere here. Okay. As one term. A into cos theta into mod B bar cross C bar. Mod B bar cross C bar. What is A cos theta here? Initially, I told you that A cos theta is nothing but the height of the A bar is not equal to height of the parallelepiped. Why? Because it is not vertical up. It is slanted like that. Slanted, somewhat slanted. So that is the reason why A bar is not along vertically up. So A cos theta is its component. A cos theta is vertically up. That is from bottom face to top face. This measurement, that is exactly A cos theta is nothing but height of the parallel pipe. So that is height into A cos theta means height multiplied by mod B bar cross C bar. What is that mod B bar cross C bar? Base area of the parallel pipe. So height into base area. Base area of parallel pipe. So height into base area of parallel pipe is nothing but volume of the parallel pipe. That is equal to volume of the parallel pipe. Okay. Height multiplied by base area of the parallel pipe is equal to volume of the parallel pipe. So you can get the total volume of the parallel pipe, that is of three-dimensional figure, right? Volume of the parallel pipe, which is equal to mod of A bar dot B bar cross C bar. So mod of A bar dot B bar cross C bar is numerically equal to volume of the parallel pipe. Volume of the parallel pipe. So the scalar product of three non-coplanar vectors. The scalar triple product of three non-coplanar vectors becomes equal to volume of the parallel pipe. Why they are non-coplanar vectors? Why? Because B bar and C bar lying in the bottom plane of the figure, but A bar is somewhat vertical up with some slanted angle. Okay, that is the reason why this is three-dimensional figure. So here A bar, B bar, C bar are not coplanar. They are not lying in same plane. Of course, B bar and C bar lying in one plane, but A bar, C bar is lying in another plane like that. A bar, this is the plane of A bar and C bar. This is the plane of B bar and C bar. Alright. What happens if all the three vectors are lying in the same plane? That is coplanar. If all the three vectors are coplanar, can we construct this kind of three-dimensional figure? We can't construct. Why? Because if A bar also lying in the plane of B bar and C bar, if A bar also lying in the plane of B bar and C bar, then we can't get height for the diagram. We can't get height. If A bar also lying in this plane of B bar and C bar, lying somewhere here, now what about A cos theta? 0. There is no height for the figure. There is no height for the figure. That is the reason why if all the three vectors are coplanar, then volume of that parallel pipe becomes equal to 0. Very important formula. That is if all A bar, B bar and C bar, if all vectors A bar, B bar and C bar are coplanar, then scalar triple product becomes equal to 0. That is A bar dot B bar cross C bar equal to 0. Implies volume of the parallel pipe also equal to 0. Implies volume of parallel pipe also 0. Okay. If you are given three coplanar vectors, if you are asked to determine the volume of parallel pipe, then definitely volume becomes equal to 0. Right? Okay. Now what about B bar dot? Suppose B bar dot, here it is A bar dot B bar cross C bar. If I take mod B bar dot C bar cross A bar, B bar dot C bar cross A bar means here B bar cross C bar in the sense bottom plane contained by these two vectors C, B, C, right? If bottom plane contained by C bar and A bar with some other orientation, if this plane is touching with the base of ground, for example, A bar and C bar. See, This is the plane of A bar and C bar. This is the plane of A bar and A bar and C bar. If the device or that figure is tilted like that, this plane touching the ground, then this could be the base. This could be the base area. Then this could be the height, b cos theta, maybe height of the parallelepiped. So with this formula also we can get the volume of the parallelepiped, right? One more thing, that is, what is that? Here it is A bar dot B bar cross C bar. Here it is B bar dot C bar cross A bar. See the sequence A, B, C. B, C, A. Next A, B, C. Next C. Mod C bar dot A bar cross B bar. C bar dot A, B, C. B, C, A. C, A. See the sequence. It follows sequence. Okay. Sequence permutation. That is mod A bar dot B bar cross C bar also equal to mod B bar dot C bar cross A bar also equal to mod C bar dot A bar cross B bar. See, in the third case, A bar cross B bar in the sense, mod A bar cross B bar is the base area of the parallelepiped. That means to say that that is tilted such that bottom plane contained by A bar and B bar. Now C cos theta becomes equal to height of the device. Height of the device. This is C bar, this is A bar, this is B bar, like that. Okay. Now in all the three cases, whether it is mod A bar dot B bar cross C bar or mod B bar dot C bar cross A bar or mod C bar dot A bar cross B bar, in all the three cases, the scalar triple product of three non-coplanar non-zero vectors always becomes equal to volume of the parallelepiped when they are taken as the coterminous edges of the parallelepiped. Coterminous edges. Coterminous edges means all are having same terminus. Same terminus means same origin. Right? So here I am writing A bar dot B bar cross C bar. Here it is B bar dot. So all are representing volume of the parallelepiped. Okay. A bar dot B bar cross C bar, mod A bar dot B bar cross C bar or mod B bar dot C bar cross A bar or mod C bar dot A bar cross B bar, all representing same value, that is volume of the parallelepiped. Volume of the parallelepiped. If all the three vectors are coplanar, then either this one or this one or this one, all are equal to 0. Right? Okay. Now how to determine scalar triple product? How to determine scalar triple product of three vectors? Okay. Right? Let us see. Let us see. Let us see the procedure of determination of scalar triple product. What is that procedure means? Here see, up to here we have one relation B bar cross C bar is so and so. Now, what is scalar triple product? The first formula, that is A bar dot B bar cross C bar. A bar dot B bar cross C bar. See, A bar is one vector, B bar cross C bar is another vector, not two vectors. B bar cross C bar is another vector. Now A bar dot B bar cross C bar. A bar means what is the vector A bar? A1i plus A2j plus A3k. What is the vector B bar cross C bar? This is B bar cross C bar. Right? Now A bar dot product. How to find dot product? Sum of product of similar components. See, multiply. This is what A bar. This is what B bar cross C bar. Take the dot product of these two vectors. Dot product of these two vectors. So we have A bar, we have B bar cross C bar. Now I dot I 1. So we left with I dot I means 1. That is A1 into this one. So A1 into B2C3 minus B3C2 Okay. Right? Now I dot j 0. So no need to take this multiple. Okay. Similarly, I dot k also 0. So other two terms are vanishing. Now coming to second multiple, that is j cap with j cap. So j cap into I cap, that is j dot I. J dot I means 0. So no need to take first term. Now this term plus of minus minus, plus of minus minus, plus of minus minus, j dot j means 1. That is 1 into a2 multiplied by this one. That is a2 into, say, a2 into second term, that is b1c3 minus b3c1 b3c1. Okay, right? Now j dot k 0, j dot k 0. So no need to take other term also. Okay, this one into this one 0. Now coming to k cap. Now k dot I. K dot I means once again 0. So this one into this one 0. Similarly, k dot j also 0. Okay, k dot j also 0. So this one into this one also 0. We left with the last term, that is k dot k 1. K dot k 1. 1 into a3 into this one. That is plus into plus k dot k 1 into a3 into this one. That is a3 multiplied by last term, that is b1c2 minus b2c1. See, this is what a bar dot b bar cross c bar. A bar dot b bar cross c bar. Exactly, this is equal to determinant of a1, a2, a3, b1, b2, b3. Okay, c1, c2, c3. Examiner once. Same can be written as determinant of a1, a2, a3, a1, a2, a3, below which b1, b2, b3, after which c1, c2, c3. a1, a2, a3, b1, b2, b3, c1, c2, c3. Examine by taking determinant of these components. Suppose exclude this column, exclude this row. Now that is a1 into exclude row and column connecting a1. We left with these four components. A, B, something like A, B, C, D. AD minus BC, that is A1 into B2C3 minus B3C2. B3C2. See, A1 into B2C3 minus B3C2. Now, minus, this time, exclude row and column connecting A2. This is what A2, somewhere here. Exclude this row and column connecting A2. We left with these four components. Now take them as A, B, C, D. This time A2 multiplied by AD minus BC, that is B1C3. B1C3 minus B3C1. B3C1. Right? Plus minus plus, that is the sequence. Plus A3 into, this time A3 into, A3 somewhere here. This time exclude row and column connecting A3. Exclude this row and column connecting A3. Now we left with B1, B2, C1, C2. Okay, take them as A, B, C, D. That is A3 multiplied by AD minus BC. A3 multiplied by AD minus BC. That is B1, C2 minus B2, C1. That's all. See, exactly this one and this one, both one and the same. That is the reason why this can be written as determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. That is equal to determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. C1, C2, C3. Am I right? So A bar dot B bar cross C bar equal to determinant of components of first vector, after which components of second vector, after which components of third vector. A bar first vector means coordinates of A bar, A1, A2, A3. B bar second vector. Okay. Afterwards components of second vector B1, B2, B3. And then components of third vector like that. This can be also written as A bar, B bar, C bar. Bracket A bar, B bar, C bar. Also can be written as A bar dot bracket A bar, B bar, C bar. See the sequence. A bar dot B bar cross C bar equal to bracket ABC. Bracket ABC. Now, what about second formula, that is B bar dot C bar cross A bar. C bar cross A bar. B bar dot A bar dot B bar cross C. Here B bar dot C bar cross A bar. Now I am writing this formula, that is, what is the first vector B bar? Now what are the coordinates for B bar, B1, B2, B3? Now write B1, B2, B3. What is the second vector C bar? Coordinates C1, C2, C3. So C1, C2, C3. What is the third vector? That is A bar. 1, 2, 3. Third vector A bar. Coordinates A1, A2, A3. A1, A2, A3. Now take the determinant line. This also can be written as BCA. See the order. B bar dot C bar cross A bar. That is BCA. Bracket B bar, C bar, A bar. Right? So this one equal to this one. This one equal to this one, which is equal to this one. This one equal to this one, which is also equal to this one. So these two are same. One and the same. One and the same. These two also one and the same. Now coming to third sequence, that is A bar dot over B bar dot over next C bar dot. That is C bar dot BC over CA over now AB. A cross B. A cross B. C bar dot A cross B. Now see, C bar is the first vector, A bar is the second vector, B bar is the third vector. Now first of all, write down components of first vector, C bar, that is C1, C2, C3. C1, C2, C3. Afterwards, second vector component, that is A bar, means A1, A2, A3. A1, A2, A3. Now coming to third vector B bar, that is B1, B2, B3. B1, B2, B3. Okay. Determinant of so and so. This time, what is the other formula? Bracket formula, that is bracket CAB. See the sequence. Bracket C bar, A bar, B bar. Bracket C bar, A bar, B bar. So, A bar dot B bar cross C bar also equal to ABC. B bar dot C bar cross A bar also equal to BCA, bracket BCA. C bar dot A bar cross B bar also equal to bracket CAB. Bracket CAB. Right? C bar, A bar, B bar. Now, same can be written as, we came across one important relation, that is dot product obeys commutative. Okay, nothing is no problem if we change order of two vectors of dot product of two vectors. That is A bar dot B bar equal to B bar dot A bar. Okay, so A bar dot this one also equal to this also can be written as A bar dot B bar cross C bar also can be written as B cross C dot A bar. So A bar dot B bar cross C bar also can be written as B bar cross C bar dot A bar. Dot product obeys commutative law. Okay. No problem with the change of order of vectors while using with the dot product, right? While dealing with the dot product. So A bar dot this one also equal to this one dot A bar. Now this also can be written as change the order. This is second vector, this is first vector. Now take this vector as first, this is vector as second, that is C bar cross A bar dot B bar. So this one also equal to this one. Now coming to this one. Now see, C bar is the first vector, A bar cross B bar is the second vector. Now take the second vector as first vector this time. That is A bar cross B bar dot C bar. So A bar dot B bar cross C bar also equal to B bar cross C bar dot A bar, which is equal to bracket A bar B bar C bar. Now B bar dot C bar cross A bar also equal to C bar cross A bar dot B bar, which also equal to B bracket B C A. Right? This time C bar dot A bar cross B bar also can be written as A bar cross B bar dot C bar, which is also equal to C bracket C bar A bar B bar. Of course, all the expressions, either this one or this one or this one or this one, either this one or this one or this one or this one, or either this one or this one or this one or this one, all are representing one thing. What is that thing? Nothing but volume of the parallelepiped. Either this formula or this one or this one or this one or this one, anything in all these expressions. Okay, ultimately this one or this one or this one or this one, this one or 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 this one, ultimately representing volume of the parallelepiped formed by three non-zero coterminous vectors as the edges of the parallel. So volume. This is also volume, this is also volume, this is also volume, this is also volume. So that is what I am writing. Bracket A bar B bar C bar equal to bracket B bar C bar A bar equal to bracket C bar A bar dot B. So A bar B bar C bar equal to bracket B C A equal to bracket C A B. All are same. Bracket ABC equal to bracket BCA equal to bracket CA. Or this one equal to this one. Or this one equal to this one equal to this one. You can write many ways. Now coming to a numerical. Suppose if all A bar, B bar and C bar are coplanar. Now what about this answer must be equal to 0. Why? Because if all are lying in the same plane, now we don't have any height for the figure. We can't construct three-dimensional device like that. So in that case, scalar triple product must be equal to 0. Let us see one example. Suppose for numerical, if A bar 3i plus 2j plus k, B bar equal to 3i plus 4j plus 5k, and C bar equal to I plus j minus pk. See, A bar is so and so, B bar is so and so, and C bar is so and so, right? Okay. If all the three vectors are coplanar, find value of P. See, in third vector C bar, Z component is not given. That is P, unknown. We need to find P value in C bar. Okay, remaining A bar and B bar, we have all the three components. Here X component 3, here Y component 2, here Z component 1. 1 into K, that is 1. Here 3, 4, 5. Here 1, 1 minus P. That is P. What is the value of P? If all are representing coplanar vectors. For coplanar vectors, what is one result? Scalar triple product must be equal to 0. That is solution C. Bracket A bar, B bar, C bar. A bar dot B bar cross C bar, otherwise. That is A bar dot B bar cross C bar. That is bracket A bar, B bar, C bar. Must be equal to 0. Now what is bracket A bar, B bar, C bar? First of all, write the components of a bar. 3, 2, 1. That is 3. First vector, second vector, third vector. First vector, components. A1, A2, A3, A1, A2, A3, B1, B2, B3, C1, C2, C3. Now take the components. A1, A2, A3. That is 3, 2, 1. 3, 2, 1. 3, 2, 1. Now B1, B2, B3. 3, 4, 5. 3, 4, 5. Now C1, C2, C3. C1 means 1. 1 into 1, 1, 1 minus P. 1, 1 minus P. These are the components for C1. Now take the determinant of these components. Must be equal to 0. Why? Because from the data itself we have one point, that is, what is that point? Coplanar. Coplanar in the sense scalar triple product is 0. That is, now exclude column and row containing 3 here. Now see, this is what 3, 2, 1. First of all, 3 into, that is 3 into AD minus BC. Exclude row and column connecting 3. This is 3. Okay. Now exclude this row and column connecting this top 3. Right? Now we left with A, B, C, D. AD minus BC. That is, AD means minus 4P. Minus 4P. Minus BC. BC means 5 into 1. Minus BC. That is 5. This time, exclude row and column connecting 2. Connecting 2. Column, row. Exclude. Now A, B, C, D. AD means minus 3P. A into D. That is 3 into minus P. That is minus 3P. Before that, we need to write here minus 2 into I into AD minus BC minus J into AD minus BC plus K into AD minus BC. So I into AD minus BC over. I into AD minus BC over. AD minus BC over. Now this time minus J. J means 2. 2 into minus 2 into AD minus 3P minus BC means 5. 5 into 1. 5. Plus K into I into AD minus BC minus J into AD minus BC plus K into AD minus. What is K here? 1. 1 and plus 1 into exclude this column and row connecting 1. Now we left with A, B, C, D. AD minus BC. AD means 3 into 1. 3. Minus BC means 4 into 1. 4. That equal to 0. That equal to 0. Right? That is, what is the multiplication here? Minus 3 4 12 minus 12p minus 15 3 5 15 minus of minus plus 2 3 6p minus of minus plus 2 5 10 3 minus 4 minus 1 into 1 minus 1 equal to 0. That is minus 12p plus 6p. That is minus 6p. Now minus 15 minus 1 minus 16 plus 10. That is minus 6 equal to 0. That is minus 6p equal to plus 6. 6 cancel, left with p equal to 1. P equal to 1. Okay. That is what p equal to 1. Okay. Alright. So one can find unknown component of any one of 3 vectors provided if all are coplanar. All are coplanar by determining scalar triple product. Scalar triple product. Okay. Right. Right. Now let us see one more sum. Something related to parallelogram law. Okay. not related to scalar triple product. That is parallelogram. Once again, see a bar plus b bar equals c bar, and a square plus b square equal to c square. Find theta. Find angle between a bar and b bar. See, a bar plus b bar equals c bar, and a square plus b square equals c square. This is the given data. With that data, we need to find angle between a bar and b bar. Now, see, c bar is the resultant of a bar and b bar. As far as parallel law of addition is concerned, what is the magnitude of resultant? Root over a square plus b square plus 2ab cos theta, that equals c. Okay, this is what parallel law of addition. Mod c bar, that is c equal to root over a square plus b square plus 2ab cos theta. On squaring a square plus b square plus 2ab cos theta equal to c square. On squaring root disappears, that is a square plus b square plus 2ab cos theta equals c square. Now, from this relation, we can write a square plus b square equal to c square. Am I right? So, a square plus b square equals c square from data. That is c square plus 2ab cos theta equal to c square. C square cancel. We left with 2ab cos theta, 2ab cos theta equal to c square minus c square, that is 0. AB not equal to 0, 2ab not equal to 0, but definitely cos theta must be equal to 0. Now what about theta? Cos theta 0 means theta is 90 degrees. Theta 90 means a bar b bar are perpendicular to each other. Right? The same sum, suppose a minus b equal c. A bar plus b bar equals c bar, and a minus b equals c. Now find the angle between small change in data. This time a minus b equals c. Now with that data, find the angle between a bar and b bar. Now this time, from this relation, a minus b equals c means on squaring we can have a square plus b square minus 2ab. A minus b whole square means a square plus b square minus 2ab equal to c square. On squaring, that is a square plus b square equal to 2ab plus c square. This is what number 2. Up to here, okay. This time, these two steps, okay. Now, instead of a square plus b square, we can have 2ab plus c square. Now, replace a square plus b square by writing 2ab plus c square. That is 2ab plus c square. Okay, a square plus b square equals so and so. Plus, write this one. That is 2ab cos theta equal to c square. Now, c square cancel. Okay, that is 2ab kept common, 2ab into 1 plus cos theta, 2ab into 1 plus cos theta equal to c square minus c square, that is 0. 2ab never be equal to 0 from data. Definitely 1 plus cos theta must be equal to 0. 0 by something, that is 0. This time cos theta must be equal to minus 1. Theta must be equal to 180 degrees. Means A bar and B bar are anti-parallel. Anti-parallel this time with this data. Correct? Okay. Now, small variation, that is A bar minus B bar equals C bar. A bar minus B bar equals C bar. A minus B equals C. Find the angle between A bar and B bar. This time A bar minus B bar equals C bar. It's not addition, this is subtraction. Okay, no problem with the subtraction. Now we have relation. What is the magnitude of, see here, root over a square plus b square minus 2ab cos theta. Minus 2ab cos theta. Small variation with this negative sign. Take here negative sign. Here also negative sign. Here also. So that is okay. A square plus b square means so and so. but a small variation, that is negative sign here, that is negative sign here, that is negative sign here, that is cos theta equal to plus 1. Now theta equal to cos theta plus 1, that is 1 means theta must be equal to 0 degrees, 0 degree. That is A bar parallel to B bar, A bar parallel to B bar, right? A small variation this time, that is A square plus B square equal to C square. A square plus B square. See, A bar minus B bar equal to C bar, but A square plus B square equal to C square. Right? A square plus B square equal to C square. Now, A bar minus B bar equal to C bar means C equal to, see, C equal to square root of A square plus B square minus 2AB cos theta. Okay. That is, I am squaring both sides. A square plus B square, A square plus B square minus 2AB cos theta equal to C square. Root disappears. That is, what is A square plus B square? This time, see, A square plus B square means A square plus B square means C square. That is C square minus 2AB cos theta equal to C square. Okay. That is C square minus C square. C square minus C square equal to plus 2AB cos theta. C square minus C square, that is 0, equal to 2AB cos theta. That is cos theta must be equal to 0. Right? That is theta must be equal to cos theta 0 means theta, what is theta? 90 degrees. Theta 90 degrees. Theta 90 degrees. Right? That is A bar perpendicular to B bar. A bar perpendicular to B bar. Right? Okay, friends. With this, we have successfully completed vectors. In next chapter, what is that? Straight line motion. In next lecture, we are going to start a new chapter, that is a straight line motion. Until then, bye. Please subscribe my channel and like my videos, share my videos and comment on my videos. Thank you friends. Bye.